AI agents just helped uncover a critical bug in Ethereum's core node software, a flaw that could take validators offline. But it wasn't a fully autonomous win. Humans were still essential to validate the exploit and sift through a mountain of false positives. We'll unpack what this means for your security strategy. And Meta faced a big backlash this week, pausing an Instagram AI image feature over consent issues, a crucial lesson for anyone building with user data. Plus, we're looking at why single camera robot navigation is about to collapse hardware costs for autonomy. No BS AI briefing brought to you by Proactive AI. Welcome back. I'm your host, Vikash Sharma, and this is where builders get straightforward AI news without the fluff. Alright, let's dive into the week's high signal items. First up, a genuinely interesting story from the crypto world. The Ethereum Foundation actually used AI agents to find a critical node bug. CoinDesk reported that these AI agents probed the Ethereum node software and surfaced a remote crash flaw in something called the gossip sublayer. It's now CVE 2026 324219. Humans then validated the exploit. What happened here is that the AI produced a ton of potential attack narratives and code, and then engineers had to filter through hundreds of false positives to find the real threat. The impact this bug could have led to remote node shutdowns, affecting validator participation across the network. Now, for builders, this is fascinating because it shows that AI can absolutely triage security at scale. It can be that high volume first responder in your infrastructure or security workflows, but human validation is still a necessary gate. Think of it as an extremely diligent but somewhat overzealous security analyst. Next, we are switching gears to a powerful real world impact story. AI scribes have reportedly cut physician burnout by a massive 74% in a study. KevinMD highlighted a Yale New Haven Health report that found this significant reduction in clinician burnout within 30 days of using ambient AI scribes. These tools handled transcription and documentation, which dramatically reduced the amount of after hours charting doctors typically have to do. As a builder, this matters because the ROI here isn't just about efficiency, it extends to talent retention, especially in high compliance, high stress settings like healthcare. When you reduce busy work for highly skilled professionals, you improve their job satisfaction and keep them from leaving. So consider how you can prioritize those invisible load reducing AI workflows in your own products. What kind of drudgery can you eliminate for your users? Also hitting the news is the launch of Phia, an AI shopping assistant, which just secured $185 million in valuation. Fortune reported that Phia raised $43 million to launch this browser integrated tool that compares prices and finds deals for users. Now, what's notable here is that the company had to address some cookie stuffing allegations, stating that fixes were implemented. This quickly brings us to a key lesson for builders. Ethical data practices and transparent consent aren't just compliance checkboxes anymore. They're becoming significant competitive levers, especially in consumer AI. When you're dealing with user data, trust is paramount. Consumers are increasingly aware, and companies like Phia, especially with high profile founders, need to be absolutely squeaky clean from day one. Then, a cool piece of hardware innovation from Mistral, they've unveiled Robostral Navigate, a model focused on single camera robot navigation. Mistral AI's blog post describes an 8 billion parameter model that can navigate purely with a single RGB camera, achieving a 76.6% score on the R2R CE Unseen benchmark. This system uses pointing-based navigation with online reinforcement learning, and it was trained entirely in simulation. Why does this matter for builders? Well, it fundamentally lowers hardware costs for autonomy. Suddenly, you don't need expensive LiDAR arrays or complex multi-sensor setups for basic navigation. This accelerates sim-to-real deployment for all sorts of logistics and service robotics applications. Imagine new product categories enabled by much cheaper, simpler autonomous systems. It's a significant step towards more pervasive and affordable robotics. And finally, a big cautionary tale. Meta paused its Instagram AI image feature amid consent backlash. The New York Times reported that Instagram's AI image tool, which used public photos on an opt out basis for its training, was quickly paused after significant pushback. This pressure came from users, talent agencies, and unions, all expressing concern over the lack of affirmative consent. While it's still active on WhatsApp and the Meta AI app, the Instagram pause is telling. For builders, this is a clear signal. Opt out consent invites both regulatory and reputational risk. It's not just about legal compliance, it's about user trust. You need to build affirmative, revocable consent by default into your AI features, especially when they touch user data or likeness. Don't learn this lesson the hard way. Now, out of all those stories, the one I really want to dig into is the Ethereum Foundation using AI agents to find that critical node bug. This isn't just a technical achievement for blockchain, it's a concrete, reproducible example of an AI assisted audit workflow applied to highly distributed, high stakes systems. It really clarifies AI's evolving role in security. So, what happened? Basically, the Ethereum Foundation unleashed AI agents, think of them as automated, tireless digital detectives, onto their node software. These agents meticulously probed the code, running through various scenarios, and eventually they surfaced a specific remote crash flaw in a crucial communication layer. This vulnerability, now officially catalogued, could have potentially allowed malicious actors to shut down Ethereum validator nodes, impacting the network's stability. The key, though, is that while AI identified the potential threat and generated attack narratives, it wasn't a fire and forget operation. Human engineers then stepped in to validate the exploit, confirm its severity, and crucially, to sift through hundreds of false positives the AI had flagged. Why does this matter right now? Well, auditing complex consensus systems like Ethereum is notoriously difficult, time consuming, and expensive. Humans are limited by scale and sometimes by blind spots. AI offers a way to perform exhaustive, high speed analysis that simply wasn't possible before. This isn't just about blockchain. Think about any critical infrastructure, any distributed system, or even large enterprise software. If AI can find a bug that could take down a global decentralized network, what could it find in your mission critical applications? This pushes AI from being a nice to have tool to a potentially indispensable part of your core security strategy, accelerating the detection phase of the security lifecycle. So, who should really care about this? Founders and product managers should care because this opens up a new category of tooling for infrastructure and security teams. You can start envisioning products that integrate AI for preemptive vulnerability hunting, potentially giving your company a faster time to patch, which is a huge competitive edge. How much faster could you ship if your pre production environment was constantly being audited by AI? Infrastructure engineers, you should absolutely be paying attention. This is a powerful new tool for your arsenal. It means you might spend less time on manual repetitive scans and more time on high level analysis and validation. It's about augmenting your capabilities, not replacing them. But it also highlights the challenge managing the signal to noise ratio of AI output. And for indie hackers, this could spark ideas for niche AI powered security services. Can you build an AI agent specialized in finding specific types of vulnerabilities in specific code bases or protocols? Maybe even a product that helps engineers filter the AI's output more effectively. How would I think about this as a builder? I think of AI in this context as an incredibly powerful, tireless intern. This intern can read every line of code, run every test permutation, and flag every suspicious pattern much faster than any human could. But like any intern, it needs supervision. It's going to generate a lot of noise alongside the signal. The strategic play here isn't to fully automate security. It's to create a symbiotic workflow where AI acts as the high volume scanner and initial triager. Then human experts step in to apply their nuanced understanding, context, and intuition to validate and prioritize. It's about maximizing human talent by offloading the grunt work to AI. You're building a smarter defense, not a fully automated one. My no BS take here is this: this isn't AI taking over security, it's AI supercharging human security efforts. The hype might suggest AI finds all the bugs effortlessly, but the reality, as the Ethereum case shows, is a high false positive load and the absolute necessity of human expertise for validation. Treat AI as an acceleration tool, a force multiplier, but never as a replacement for skilled human security work. It's about getting more done with the same or even fewer human resources. But those humans remain the ultimate decision makers. If you want one practical takeaway from today's episode, especially in light of the Ethereum bug story, here it is. Experiment. Run AI assisted code review on a non critical repository in your team this week. Here's how to try it in under 60 minutes. First, pick a small non critical code base or a module within a larger project that you don't mind getting a little experimental with. Maybe it's an internal tool, an old side project, or a non production microservice. The key is non critical to keep the risk low. Next, use an existing large language model like a Claude or a GPT model, or even a fine-tuned open source model if you have access, and prompt it to act as a security auditor. Give it sections of your code and ask it to identify potential security vulnerabilities, edge cases, or logical flaws that could lead to exploits. Ask it to generate 5 to 10 speculative issues based on that code. Push it to think like an attacker. Finally, have one or two of your engineers, ideally security minded developers, review the AI's findings. Their job isn't to fix the code yet, but to validate each issue. Is it a real vulnerability? Is it a false positive? Is it an interesting but low priority observation? Tally the signal versus the noise. How many genuine issues did the AI find compared to how many it hallucinated or got wrong? Why is this specific experiment worth your time right now? Because it's a low cost, high learning way to understand the practical capabilities and, crucially, the limitations of AI in a real world engineering context. You'll get a first hand feel for that false positive rate, which is often much higher than the marketing claims suggest. It helps you set realistic expectations, identify where AI actually can accelerate your team, and perhaps even spark ideas for custom internal tooling to better integrate AI into your specific development and security pipelines. It's about moving beyond the theoretical and into empirical data for your team. That's it for today's No BS AI briefing. If this helped, follow the show in your podcast app and share it with one builder you know. And if you've got questions or topics you want covered, connect with me on LinkedIn and send them over. See you in the next briefing.